Hi, good morning, third graders. I'm so happy to be talking to you this morning. I hope you guys are having a great week and you just had a great weekend. I want to say good morning to Demarvion and Alicia and hi, Kennedy, hi, Journey, hi to Dream, and good morning, Amaya and Cassius, and hi to Cameron. Hope you guys are all fabulous and wonderful. This morning we will be going over our week 4 learning packets from April the 13th through April the 17th. So let's just get started. As always, I'm going to hold the paper up so you can see what page I'm working on, and you can fast forward or rewind to the part that you need. So the very first page, as usual, has some expectations for you on the top and some tools for doing math on the bottom, a place value chart, and a hundreds chart. On the back of that page is identifying equivalent fractions. Now, you guys did some work with this last week as well, and so now we're doing the next step. Now, a couple of things that I want to says write in the numerators and the denominators for each part that's missing. Okay, so these are all empty fractions here underneath our fraction models. Now let's look at the example first. And so here it says, here's our fraction model is cut into 4 pieces. So as usual, 4 is our denominator. That tells how many pieces altogether of the whole are we looking at. And then we notice that 1 out of 4 pieces is colored, 4 altogether, 1 of them colored. 1 is going to be our numerator. 1/4 is the fraction that is represented here. And it's showing us that it's equivalent to, now if I just am looking at these, I can see, especially if I move back here, that these two shapes are exactly the same amount of pizza or pie or whatever you're sharing here, okay? If this was a delicious apple pie and someone gave me this piece and someone gave my neighbor this much, would we have the same amount altogether? Sure. The difference is that my neighbor's piece, we have the same amount altogether, but my neighbor's piece is cut into 2 pieces, okay? This pie was cut into 8 pieces altogether. So instead of just 1 slice, it's going to take 2 slices to equal the same amount of pie or pizza, okay? So I'm just filling these in. Now, a couple of things, you can just look at each one and say, oh, this is 1 piece colored out of 4 total pieces. Oh, that's 2 pieces colored out of 8 pieces total. And you can fill your fractions in that way, that's fine. One thing to look at is to make sure it doesn't matter that this is yellow and this is green. The colors don't matter at all. What matters is that it's the same amount of the whole circle, okay, that's taken up. The other thing to look at, so you probably want to check that every time, make sure that it is actually the same amount, but they're all equivalent fractions, I think they're going to be. The other thing to look at, if you would like to check your work, okay, if you can do the same thing to the top and the bottom, I'll show you what I'm talking about in a second, then we know that we've pretty much got it correct. So let me check right here and think. To go from a smaller fraction to the larger numbers, we know it's an equivalent fraction. It's not actually a larger fraction, but it has more pieces. To find an equivalent fraction, if I can take my number 1 and multiply it by something to get 2, let me think. 1 times what is going to equal 2? Well, because of the rule of 1, I know always that 1 times the number is going to equal the number. So it must be 1 times 2. 1 times 2 equals 2. So that's what I did to the bottom to or to the top, I'm sorry, to get my new equivalent number, I need to make sure that I'm doing times 2, the same thing to my denominator, to the bottom of my fraction. Okay? 4 times 2, let me test it. Does that equal 8? Yes. So 1 times 2 is 2. 4 times 2 is 8. I can do the same thing to the numerator and the denominator, and I will get an equivalent fraction. Okay? Let's just check one. Miss Camille, I'm going to tell you a hint right up front. I'm going to make a mistake on this one. See if you can spot it before I explain it, okay? But don't copy this one because I'm gonna make a mistake. I want to show you how you might catch yourself if you had made a mistake. Okay, so I'm going to get out my magic pencil. Oops. Okay, it's my magic pencil. It's actually pencil. And I'm going to look at this and I'm going to say, okay, how many pieces here? I've got 1, 2, 3, 4. I've got 6 pieces there. And, oops. How many of those are colored? 1, 2, 3. 3. Okay, so this fraction represents 3, 6. Okay, and then I'm going to come over here and I'm going to look at my pieces and I'm going to say, well, there's 1 colored and 1 not colored. Okay, so what I'm saying right now, remember I'm making a mistake. See if you can figure out what did I do wrong. Okay, what I'm saying right now is that this fraction shows me 3/6 of this pie is colored. And this fraction shows me, 1 out of 1 is colored. Now it already looks a little funny, but let me check my math, okay? Let's see. Now I cannot multiply, but the opposite of multiplying is dividing, okay? So 3 divided by what is going to equal 1? Well, if I have, that's my rule of 1 still. 1 times 3 is 3. 3 divided by 3 friends, we would each get 1. So 3 divided by 3 equals 1. Okay, so you see I'm using division here. Okay, 3 divided by 3 equals 1. Let me try to do the same thing to the bottom. 6 divided by 3. Okay, now wait a minute. If 3 divided by 3 is 1, can 6 divided by 3 be 1? Gosh, that doesn't make any sense. Let me try it. Let's see if I had 6 cookies and 3 friends. These are my 3 friends, and I'd say 1, 2, 3 cookies, 4, 5, 6. No, 6 divided by 3 is 2. Well, my test, doing the same thing to the top and bottom, didn't work out. Let's see, maybe I need to take a second look. Could this be 2? Here at the, oh my goodness, my test helped me realize where I made a mistake. The bottom number needs to be the total number of pieces. There are 2 pieces. Oh my goodness. There we go. There we go. Now I've made everything true. Okay, 3 divided by 3 is 1. 6 divided by 3 equals 2. So my fractions are equivalent. 3/6 is equivalent to 1/2. And now that I look back at my circle, oh, sure enough, the colored part, it shows me 1/2. So go ahead and go through and try to write down the answers for your fractions, but then use your multiplication and division. You have to do the same thing to the top and the bottom. And if it works, then you've got it right. If it doesn't work, it's going to point to, oops, I made a mistake on one part of this. Okay, so then you have to go back. You can start over and check your math. Remember, going from a smaller number to a larger number, I'm going to multiply. Going from a larger number to a smaller number, I'm going to need to divide. Okay, So that's just a way to check your equivalent fractions. My wonderful helper, Wolfgang, who is my fluffy cat, helped me get the papers out of the printer again today, and so I have an extra copy of this one that's all chewed up. So excuse me while it takes me just a moment to get the next. Here we go. This is your next page, counting money, pennies, nickels, dimes, and quarters. We've done a couple of times strategies for these. I tend to start with the largest coin first, unless I have some quarters, in which case I like to combine a quarter with a nickel to make a nice 10 friendly even number. So here at the top, my largest value in here, I've got pennies, dimes, and nickels. The largest value is dimes, 10, 20, 30, 35, 40, 46 pigeons sitting on a wire. Nope, it's 46 cents. I'm going to write that on the answer here. An example with quarters. I'm going to look through my line first, and I actually see I have 1, 2, 3 quarters. And I remember just from working with quarters that 3 quarters is going to be 75 cents. 25, 25 and 25 is 50. 50 and another 25 is 75 cents. Now that does not give me an easily countable number, so I like to take my 75 cents and put a nickel on it to make it 80. Count my next dime, 90, 1 nickel left, 95, and a penny is 96 cents. Whatever strategy you want to use, adding up your coins here on the side. Wonderful. A little arrays review. Color in squares to solve the multiplication equation. All right, so the most important thing to remember with arrays, one number is going to tell you how many are in a row, and the other number is going to tell you how many rows. Okay, now 3 times 3, it's pretty hard to mess it up because it's both the number 3. So let's look at 5 times 6. Now, I might even, to help myself out, I might think about this 5 as a 5 bar. Okay, and for me, and so those are light blue, right, in our multiplication box. 3, 4, 5. I know they're 5 long, okay? I'm going to think of them as going horizontally. So I'm going to use my grid. That's just an example one. I'm going to use my grid, and I'm going to color in a 5 bar. 1, 2, 3, 4, 5. Okay? That is how many are in a row. How many in one row? 5. Okay? The other number tells me how many rows. So right now I just did 1 row. I just did it 1 time. That's 5 taken 1 time. Right? So I need to make sure that I take it 6 times. So that's 5 1 time. I'm just going to do it really, really quick. 2, 3, 4, 5. 5 2 times. 3, 5 3 times. 2, 3, 4, 5. 5 4 times. 1, 2, 3, 4, 5. 5 5 times. Just want you to kind of notice that this is becoming a square. 5 5 times. But that's still not enough because it told me to have 6 rows. 1, 2, 3, 4, 5. There we go. 6 times. And let me check. Here is 5 1 time, 2 times, 3, 4, 5, 6. 5 6 times. This is what your array should look like. Okay, so again, even though we might know what 5 6 times is, and we might already know the answer. We're going to use our array model. We're practicing making our model. It's like our area model. It is reminding us that arrays can show space. And then to find the answer, I'm just going to count. I'm going to skip count 5 in this row, 10, 15, 20, 25, 30, 5 taken 6 times is 30, and write my answer there. Okay, so array models. Page 40, it is your, or it says page 40 at the bottom anyway, it is your ELA reading, writing, reading comprehension work for the week. This one is actually really super interesting. It says Galileo and the telescope. And so Galileo is actually a, well, we're going to find out about him as a person. And he was a scientist and a curious person, always making a lot of really interesting observations. And actually, we still learn from and use his observations today while we investigate the world. So Galileo and the telescope. So I'm kind of giving myself some pre-knowledge. I'm thinking I'm going to hear about the scientist. It's Galileo and the telescope. What do I use a telescope for? Looking out, seeing space, far away. So I bet that my passage is going to be something about this person making observations using his telescope. And I'm really excited to learn more about that. So go ahead, you can pause now, read the passage to yourself, read the passage with a grown-up. If you have any tricky words, do feel free to send me a message in Schoology if you would like. So you can pause now, give yourself a chance to look over the passage, read it 1 time, 2 times, maybe even 3 times, really focus on the details, and then restart it when you're ready, and we will go over the questions. Okay, the questions here at the bottom. Number 1, it says, Galileo's father was disappointed when he became a mathematician. What did he want him to be instead? It's really just checking for reading details, okay? So reading details as you read, what did Galileo's father want him to be instead of a mathematician? Number 2, why did Galileo become an inventor? It's not how did he become an inventor, it's not what did he invent, the question is why. So read through here to find Galileo's reasons for becoming an inventor. Why? Question 3, where did Galileo get the idea for his telescope? Again, I know that this passage was largely one of the main ideas is about a telescope. So I'm positive it says in here where he got his idea for a telescope. So read through here and think what gave him that idea. And number 4, what did Galileo discover about the moon? Reading through here, find the detail. Your answer should be in a full sentence, something like, Galileo discovered, about the moon.